Hi, it's Mr. Anderson, and this is AP Physics Essentials 007. It's on positive and negative charges. Imagine I take a balloon that doesn't have a charge and I rub it on my head. I'm now giving it a charge, so I can move it up to something neutral, like a wall, and if I let it go, it'll just stay there. Now imagine if I take another balloon and I charge that in a similar manner. It should have the same charge as the balloon, and so if I hold it up next to it and let it go, what's going to happen? It'll actually be repelled by that object. And so scientists speculated there are two types of charges, and we call those positive and negative charges. And so an electric charge can be positive or negative. If we have a neutral object, it's going to have an equal amount of each of those different charges. But if it's a charged object, like a balloon, then it's going to have differences in the number of electric charges that it has. If it's a negatively charged object, it's going to have more of the negative charges. And if it's a positively charged object, it's going to have more of the positives. Now let's say I bring two objects next to each other that have different charges. What's going to happen? There will be an attractive force between the two. But if we take two objects that have the same charge and bring them next to each other, that could be both positive or both negative, they're going to repel each other. Now, why did the balloon stick to the wall if the wall didn't have a charge? I hadn't done anything to it. Well, if you move a charge up to a neutral object, what it can do is it can polarize that object. It can move some of the charges to one end, and what it does is create a somewhat charged object. So an electric charge can either be positive or negative. And so if we're looking at a neutral object, how many of those charges are we going to have in that object? An equal amount of each. Now let's say we take a charged object like that balloon. What are we going to have? We're going to have more of a positive charge if it's a positively charged object, or if it's a negatively charged object, we're going to have more of the negative charges inside it. Now, let's say we take two neutral objects, so two balloons that we haven't charged, and we move them right next to each other. What's going to happen if we let them go? Nothing's going to happen. There's going to be no attraction between the two because the charges are equally distributed. Let's say we take two objects that have opposite charge. So the one on the left has a negative charge, one on the right is going to have a positive charge. If I let these go, what's going to happen? There'll be an attractive force between the two. Opposites attract. Let's say we take two objects have the same charge and move them next to each other. In this case, they both have negative charges. What will happen when I let go? They're going to push away from each other. Same thing if they're both positive. If I let them go, they're going to move away from each other. Now let's say we take a charged object, so that's the one on the left, and then we have a neutral object, that's going to be the one on the right. Watch carefully what happens as these two come together. So as I move the charged object towards the neutral object, what it's doing is it's polarizing those charges. It's moving the negative charges farther away. Why? Because they're being repelled by these negative charges. The positive charges are moving towards it. And so now there's an attraction between this polarized, what used to be neutral object. And so PHET makes a wonderful simulation that kind of walks you through that. So what we've got, here's the address down below, and I'll put a link in the video description as well. So what I'm going to do is take a balloon, and I can move that balloon around, and if I let it go, it just stays where it is. But let's say I want to charge it. What I can do is I can rub it on a sweater like this, and now I'm applying a charge to that balloon. So when I let it go, it's going to go right over to the sweater. And so if we move it next to the wall and let it go, it'll stay there. But if I get it close to the sweater, then it's going to be attracted. And so let's reset this whole thing and look at the charges now. So you can see that all these objects are now neutral. They have equal amounts of charge. But as I rub it on the sweater, what I'm really doing is I'm pulling those negative charges off the sweater, and now they're on the balloon. So now that balloon is a negatively charged object, and the sweater is a positively charged object. So if I let it go, it moves right next to it. Now, watch what happens when I move it next to the wall. You can see it's polarizing this neutral object of the wall. So I'm not transferring charges, but if I move it next to it, it's attracted. Let's get two balloons now and remove the wall. So let me add negative charges on this green balloon right here. And now let me add more negative charges on this yellow balloon. What's going to happen? Well, as I move that balloon next to the other balloon, these are
leg charges.
And so you can see that they're repelling each other, and it eventually would like to go back to that sweater. Okay, so did you learn the following? To explain a two-charge model of electric charge, again, if it's a neutral object, we're going to have equal amounts of each of those two different charges. Did you learn that the distribution of those charges tells us if the object is going to be positively charged or negatively? You can see this would be a negatively charged object here. And then finally, did you learn to explain how the polarization of electric charge or separation of that charge in a neutral object can lead to an attraction? So we have an attractive force here between a charged balloon and what used to be a neutral wall. I hope so, and I hope that was helpful.